Okay, so let's talk about 1997 mechanics number 1. And even if we only talk about A and B, that'll be okay because we could talk about how to do C, because part of C is really just solving a projectile motion problem that you already know how to do. Okay? So part A says for one or both, from one or both of the graphs, determine A and show your work and how you specify the units. So the first graph, which was force versus distance, kind of looks like that. And the second graph, which was force versus the square root of x, kind of looks like that. And we know that f of x goes as a radical x, or a x to the 1/2. So how do you figure out a? Zoe, what did you do? Okay. Okay, so this is really the equation or the expression for this graph. And in that case, A is the slope of that graph, okay? Which is why not astronomers, but scientists in general will graph a lot of weird stuff so that they can have a straight line, because you can always find the slope of a straight line, okay? So what I want to tell you is a couple of things. The person who took the data here drew a best fit line. The point of a best fit line is that it takes into account all of the data. So when you are finding the slope of a best fit line, you should never pick data points. Okay? You should always just pick two convenient places where the best fit line cross the grid intersections or something. Okay? But that's just like a good scientific practice. All right? So, Elisa, what'd you get for part A? Okay, or meters to the 1/2. What did anybody else get? You got 25? Okay, I got 25.5 myself. But in a problem like this, they'll always give you a range of acceptable values, so that if you estimate where the best fit line crosses the grid lines a little bit differently, it'll be okay. All right? Okay, well, let me finish saying that. The problem with that is that you're only taking the data from one point, and that is not a good practice. Okay, we'll talk about this